Hello students, welcome to the experimental setup of this experiment to find the velocity of ultrasonic waves in water or any other liquid. So this is the power supply and this is the ultrasonic interferometer setup. So you can see here there is a on off switch here, and then you have a microammeter. Then these two are the zero adjustments, these two. This is a zero adjustment and this is a range adjustment. This is the supply, and I will connect this lead. This lead will be connected from the other side to this cylinder, and I can show you that if I open this knob, then you can see at the bottom of the cylinder there is a metallic pin. This metallic pin will get the supply from this lead. So let me just connect this lead with the base of this cylinder from one side. So the other side of the lead will be connected to this terminal, this port. So the connections should not be loose. These must be tight. Now this connection is okay. Now you can see there is a pin. If I show you this cylinder, it has a bottom, there is a pin. There is a pin here, and at the bottom of this cylinder there is a hole. So if I put this here, then this pin will enter into the hole, and it will be, actually there will be a spring around this pin in the bottom. I cannot show you that, but it is there, and on the spring there is a disc, and that disc will be in the contact of this water. Now let me show you about this cylinder from inside. If I show you this cylinder, if I open it, and now I have opened this cylinder, you can see here this is a piston, and you can see here I have filled this cylinder with water. I guess you can see this water. So this piston which I am touching, this is the bottom of the piston. So the other end of the piston is passing through this rod, and it is attached to this screw gauze. Of course it's I will show you it otherwise. Of course its least count is quite less, or it is more accurate. Now you can see here there is this one, there is a problem of autofocusing. Yes, this one is the main scale and this is the circular scale. Now you can see the 45 written on this is on the circular scale, and if you are seeing this 0, 1, 2 horizontally, this is the main scale. You can see there are actually markings below also. These are engraved markings, and similarly you can see this is circular scale. You can see there are 50 divisions on the circular scale, and if I open this main scale, it can open up to 25 millimeter. I will not show all. Now you can see 5 mm has been opened on the main scale. Okay, so this horizontal line is if you can see here, there is a horizontal line. This is the reference line. I have to match, for example, now 15 of circular scale is matching with the reference line, and now 10 of the circular scale is matching with the reference line. If I rotate the screw in this direction, then the circular scale reading is increasing. In this direction, the circular scale reading is decreasing. So let me now put this piston into this cylinder which is filled with water. So this cylinder is now being, you will gently release it. Okay, after gently releasing it, so we will, I am going to tighten this knob so that it becomes tight. So now this is now tight. Now I will, because it is still loose, so I will now tighten up this screw. So I have tightened up both of these screws. Now there is a time to take the readings. When I rotate this screw clockwise, then this rod which is attached to the piston, this piston, bottom of the piston is somewhere here in the cylinder. So if I rotate this screw clockwise, this piston will go down, and if I rotate this screw anti-clockwise, this piston will move up in the water. So let me move it slightly downward so that there is a provision not to move it anywhere. If I press, I have already started the main lead. Now I will switch it on from here. So you can see there is some reading given by this micrometer. So if you can see here, this reading is somewhere between 50 to 60 microamperes. We will usually keep this range. 50 to 60 microampere is good actually for us. Now I am going to rotate this screw. So when I will rotate this screw like this, I am moving it anti-clockwise so that it moves up. Then you will see this needle will show deflection. Let me show that. I am now moving it upward and the needle is going toward the right side. Now it is going toward left. Again it is going toward right. Now it is going toward left. Again it is going toward right side. So this is how you can verify that stationary waves have been formed in the water and there is a node and antinode formation. Wherever the current will be maximum, it will be node, and wherever the current will be minimum, it will be antinode. So this reading, if this reading I am moving it, again I will move it. So this reading is going maximum up to 78 or 79 micrometer, I guess. Let me refocus the camera. Okay. So it is going up to 78 micrometer and it is coming up to 50 micrometer. So this is good. So please remember 78 is my global maxima and 50 is my global minima. In between there is let us say needle is changing its direction from 63 micrometer and 59 micrometer. Please remember 63 is a local maximum and 59 is a local minimum. Before starting the experiment, we have to identify the global maximum and global minimum. Okay, so now we have identified that global maximum is 78 and global minimum is roughly around 50 micrometer. So we will take the readings. We will take the readings only when the needle will touch these two values. So we will not be confused from the local maximum and local minimum. If I rotate this screw you can see the needle is moving away and then it returns back. Now this is a limitation of the camera. I cannot simultaneously focus this camera on screw as well as the needle. So this I have kept unfocused. This screw I have kept as focused. So you can just see the needle moving. I have already told you that the local maxima is somewhere around 78 and the local minima is somewhere around 50. So if I move it, now you can see the readings are decreasing and the screw is moving clockwise. It means piston is moving down. So I would not take the readings by moving the screw down. Now this 0 is in contact with the reference line. So this is our 0 of the circular scale and this is the reference line of the main scale. This is 0, 1, 2, 3, 4, 5 and on this side I will not show you, I will show it later. This is the reference line. To the left of the reference side we have integers divisions. To the right of this reference line on the main scale we have half integer. Actually 0 is here, 0.5 will be on this side, 1 will be on this side, 1.5 will be on this side, 2 will be on this side, 2.5 will be on this side. So I will show you later on. So let me take the readings now. So I will now move this screw upward, that is anti-clockwise, so that the readings of the screw will start increasing. Now you can see this has reached near about 80 and it has now turned back. It is now just changing its path. So it is a global maximum and the needle is at its maximum position. If you see the reading of the screw gauge, then the screw gauge is showing me some reading and that reading I would call it to be x1. So this x1 reading, for this x1 reading, if I take a closer look up at the screw gauge, so you can see the main scale reading is 0, 0.1, 5, 2, 1, 1.5, 2, 2.5, 3, 3.5 and 4. So main scale reading is 4 and the circular scale reading is more than 10 and less than 11. So we will always take the smallest. If the reference line is between two circular scale divisions, then you will always take the smallest of the two. Now you can see this reference line is between the 10th and 11th division of the circular scale. This is the reference line, this is the reference line and it is between 10th and 11th. So we will always take 10th. And on this side you can see here that 0 is visible, 1 is visible, 2 is visible, 3 is visible, 4 is visible. And on this side, yes, you can see that 0.5, 1.5, 2.5 and 3.5 is visible, 4.5 is not visible. So the maximum reading that is visible on the main scale reading is 4.5 mm. So on the copy I will write x1 is equal to main scale reading plus circular scale reading. It will be sum of both. Now the main scale reading is actually, it was between the maximum reading which was visible, that was 4 mm. And the circular scale reading is actually the number of division multiplied by the least count. The least count of this screw gauge is actually 1 by 100 mm. So rather than calling it micrometer, I would call it as screw gauge, because least count is still 1 by 100 mm. It will be 0.01 mm. So therefore my reading of x1, which is the first node that I have noticed, it will be 4 plus 10 was the coinciding reading into 1 by 100. It will become 4.10 mm. So this is the reading of the first node. Let me now move it anti-clockwise, and you can see this needle is coming. You can see this needle is moving to the left. Let me check the reading of the screw. You can see now yes, you can see now initially 4 was visible. Now this is 0, 1, 2, 3, 4. Now 4 is clearly visible. Earlier it was just visible. You can see here this is 1, 0.5, 1, 1.5, 2.5, 3.5. So 4.5 is still not visible, and the reading on the circular scale is now between 46 and 47. So we will take it to be 46. So my value of second node is x2, which will be equal to 4 plus 46 into least count, that is 1 by 100. It will be simply equal to 4.46 millimeter. So this is at maximum and this is at 46. Now I will rotate. I will try to show you both of the things in a single shot. So you can see here the needle is also and the screw is also. I will move it further anti-clockwise. So the needle is moving to the left and I am moving the screw upward. So this is a local minimum. We will ignore this local minimum and local maximum. Now the needle is approaching toward global maximum. So I would move it here. So you can see. And this is okay. Now it has changed its direction. The needle has just started moving down. Let me take the reading of the screw. Okay, now you can see it clearly. This screw is now, if you watch it, this is 0.5, 1.5, 2.5, 3.5, 4.5 is now visible. On this side you can see 0, 1, 2, 3 and 4. 5 is not visible but 4.5 is visible. So on this side the visible reading is 4.5. On this side the visible reading is 4. So since 4.5 is bigger than the 4, so therefore screw gauge reading, main scale reading is now 4.5 mm. And on the circular scale you can see this is 30, this is 31, this is 32, this is 33, and you can see reference line is in contact with 34. So I will take the main scale reading to be 4.5 and circular scale reading to be 34. So my next node is at x3, which will be equal to 4.5 plus 34 into least count, that is 1 by 100. That will become equal to 4.84 millimeter. So now we are at the local global maximum. The circular scale reading is 4.84. So I will now not shift focus because you have seen so many readings combinedly. Now I will move the screw upward and I will now focus the needle. Okay, it is moving to the left. You can see it is very well focused now. Video is very well focused. So it is moving to the left and antinode has passed. This is to be ignored. This is local maximum, this is local minimum. We will ignore this. Now it is moving toward global maximum, which was near about 80. So okay, you can see needle has changed its direction again toward the left. So it is a global maximum. Now we will take the reading. You can see clearly here, if you are able to see this is 4.5. I guess you are mature enough, there is no need of me counting every division now. So this is 4.5 and this is 5. From this side 4.5 mm is visible, from this side 5 mm is visible. So bigger of these two is 5. So I will take the reading of main scale to be 5 mm. And if you see this reading, now this main scale, this is 20, this is 21, this is 22, this is 23, this is 24. So the reference line on the main scale is between 23 and 24. So I will take the circular scale division to be 23. So my next node, which is at x4 is actually, this is 5 mm plus it was 23 into least count, and this is equal to 5.23 millimeter. Okay, now we want to find the distance between the consecutive nodes. So now we have, I will make a summary here. Now we have x1 equal to 4.10 mm, x2 equal to 4.46 mm, x3 is equal to 4.84 mm, and x4 equal to 5.23 mm. Now D1 is the distance between two consecutive nodes. It will be equal to x2 minus x1. It will be equal to 4.46 minus 4.10. This will be equal to 0.36 mm. Next, D2, node distance between second node and third node. It will be 4.84 minus 4.46. So this distance will be equal to 0.3 and 8 mm. And D3, it is the distance between third node and fourth node. It will be x4 minus x3. It will be x4 minus x3. It will be equal to 5.23 This is 5.23 minus 4.84. This is actually 3, this is 2. So it will be 0.39 mm. Now we have found three values. So the average value of D, it is given by D1 plus D2 plus D3 upon 3, because I have made 3 observation. It was 0.36, 38 and 39. It was 0.36 plus 0.38 plus 0.39 upon 3. That will be equal to, it will be equal to 1.13 upon 3. That will be equal to 0.37 mm. So you can round off, you can use rounding off. So average value of D will be equal to 0.38 mm. So we can now find the value of the speed of ultrasonic waves in water by using the formula that I will now describe on my graphic tablet. Thank you.